Welcome everyone to another video where I'm going to work through an example. So this is a really important example from the end of Module 4 and the module questions. It's relating to compound interest and then also working out compounding interest with non-annual periods. So first off, we're going to calculate A here. So the question is, your grandmother just gave you $6,000 and you'd like to see what it might grow to if you invest it. So for part A here, calculate the future value of $6,000 given that it will be invested for 5 years at an annual interest rate of 6%. So the formula we're going to use is future value equals present value outside in brackets 1 plus the interest rate divided by the number of periods in that you're going to be compounding to the power of years, which can be n, multiplied by the number of periods again. So it can be a little bit worded differently on your formula sheet, but this is the one I like to use, and sometimes you can substitute it in, but this is the best way when I explain it once we go to the compounding of periods. So this one again, so future value equals $6,000. Right now we're going to have 1 plus the interest rate of 0.06. For part A, we are compounding it annually, so we're going to divide that by 1. And once again, it's going to be for 5 years, so the power of 5 times 1. So now I'm just going to simplify this formula down. We've got 6,000 outside 1.06 to the power of 5. And then to give us our calculation, our answer is 8,029.35 cents. So moving on now, we're going to work on to using a compound period for the same question in part B here, that is semi-annually first. So once again, we're going to use our formula, so future value equals present value outside 1 plus I divided by m to the power of n times m. I do use a little asterisk here, but it is a multiplication symbol. So with this, we're going to do future value equals, once again, $6,000 outside 1 plus the interest rate, 0.06, divided by 2, because semi-annually, so it's going to be compounding twice a year, to the power of 5 times 2. So once again, semi-annually. So simplifying this formula down again, to the power of 10. And this gives us an answer of 8,063.49 cents. So it is a little bit higher because it does compound that period semi-annually, so it does compound at the 6-month mark. So now I'm just going to have a look at one where we're going to do monthly now. So I'm going to skip to the last one that I've got in this question here. Same formula again, so future value equals present value outside 1 plus the interest rate divided by the compounding periods to the power of n times, once again, the compounding periods. Well, so we've just skipped across the other page. What I might do is I might make this a little bit smaller so we stay on the same page. Working through the formula again, we're going to have 1 substituting in 0.06 for interest rate, so 6%, divided by 12 to the power of 5 times 12. So then once simplifying it down again, we're going to have 6,000 outside 1.005 to the power of 60, which will give us a final answer of 8,093.10 cents. So there you are. So I have adapted this question from 4.7 at the end of the module. There is some extension parts of that. I'd like everyone to have a crack where it does work on to using an interest rate of 12%. As I said, this is a really important question for developing your understanding around interest rates and compounding and future and present values, and really important in terms of some understanding for the module content as well as the rest of the unit. And if you have any questions, please feel free to post them underneath this announcement. Thank you.